Hey guys and gals, Insomnia from UnrealTech.net here, division of BlenderTek.com. Welcome to the second video in the Intro to Programming 101 through Python course. Today we'll be looking at some of the very basics of the Python language. We'll go through some parts of the syntax, which is basically rules that you have to follow when writing things. For example, text has to be in quotes and other little things. For example, when I call print to print a message that has text in it, the text needs to be surrounded in brackets. That's syntax. We'll be going over that, as well as a few of the basics of the language and also any programming language, such as things like variables, different kinds of variables. We're going to go over whitespace, which I said in the last video is spaces, so those characters. Tab, the tab key, that's what Python uses to differentiate between certain things. This is another thing. We will go over comments, so that's things like the compiler won't read this, but it will read this and give us an error. Yeah, that'll be today's intro lesson. So let's get started. Now remember that we are using the Python 2.7 idle environment. So that is opened in your start menu under P, and remember our motto, create your way. So writing programs, applications, games, that all involves storing, using, going back to, and working with different types of data. Data such as numbers like 1, 2, 3, 3.14 or whatever. What's called a string, so that's like a sentence. So a string would be like hello world, and that could involve pretty much any character, letter, symbol, whatever, as long as it's in the quotes. These are all different types of data, and those are the basic types. So let's start with a simple way to store data. Let's start by creating our first lesson's Python file. So let's go File, New, and we're gonna go Language, P, Python. Now let's go File, Save As, and let's make a folder for ourselves so that we always know where to find this stuff. So I've gone ahead and created one. So I'm going to call this lesson02.py. You'll see it already knows to save it as a .py because we set the language. So with our lesson02.python file, let's begin. So let's create a variable. So a variable usually has a name, so something like my variable, and then we give it a single equal sign. So we're saying my variable name is equal to something. So let's say it's equal to a number like 25. So what we're saying here is my variable name is equal to 25. So whenever I ask for my variable name, I'm actually asking for 25. And so you can think of variables like containers. So my variable name is a container that holds the number 25 in it. Pretty basic understanding that's used in all languages. Variables are containers. So you could say a number container 01 is equal to the number 25. So our number container 01, that's what we've called it, a number container 01 is equal to 25. So if we call one of the most basic statements the print statement, so that's called by typing in print, and then you'll see it's highlighted, and then we open and close brackets and open and close quotes, because remember that sentences need to have quotes around them, quotation marks. If we were to say something like 25, that would print 25. Let's go ahead and test that. Let's copy this and put it into our Python environment, our idle environment. If you don't have this, you can just open up the Python shell, the idle, and then go File, Open, and then open the file that we just created, the lesson02 file. So let's run our program. So we have our variable called a number container 01 is equal to 25. It holds the number 25, and then we're printing the number 25. So let's run that. Remember the hotkey's F5, so run module. So as you can see, it opens up the shell and we get 25 printed out. However, the power of having variables is if we wanted to print the number 25, since we already have it stored in a container, a container, think of a variable like a container, in our variable called a number container 01, we can do this. Print, open and close bracket of course, a number container 01. So let's try that out now. Let's go run module. We want to save it. As you see, we get 25 out, just the same as if we had printed 25 itself. So we can store anything in our variables. So if we said a string container, and you can name it anything you want. I can go ABC equals hello, and then if we printed that instead, what we get is hello. So you can store almost anything. You could even go so far as to go 1 plus 5 and running that, and you'll see we get 6. You can also combine them. So we can say, let's make our names a little simpler. The general rule is you want your variable names to be as short as possible, but descriptive at the same time. So let's just call this num1 for number 1. Let's make another one called num2 equals 3. So what we can do is we can print, and we can print num1 minus num2. So what would you expect? 6 and 3. Let's find out. Run module. We get 3. So you can combine them that way as well. However, these will not change. Just because we subtracted doesn't mean it changes. If we go ahead and print them right afterwards, so print num1, print num2, if we run that, you'll see that we get 3 and then 6 and 3. The numbers haven't changed. So we don't change the number when we print out something like that, but we can change the numbers. We'll get to that a little later. So basically, think of a variable as a named container. So we give it a name, we give it an equals sign, and then we give it what's called a value for data, a data value. So that can be a number, a string with quotes, it can be a math expression, it can be basically anything, a single character, and so on and so forth. So name equals data value. So that is variables. One variable that we haven't gone over, however, that is very powerful and important is what's called a Boolean, and that's spelled Boolean like that. Boolean, and it's shortened usually to bool. Numbers are our primary data type, so you do a lot of work with just plain numbers, but another very important one is a Boolean. And a Boolean's just like a switch, like the light switch on your wall. It only can go 2 ways. It can be true or false. So just like your light switch, it can be on or off, not both, not in between. It can only be one or the other. So Boolean is equal to true or false. And sometimes that's shortened to T or F, and sometimes that's shortened to 1 or 0. So what we can do is we can say, let's go bool 1, since we learned that variables are contained for data and they should be as short and descriptive as possible. So this is our first Boolean, equals true. What we can do now is we can say print bool 1, and let's see what we get. So let's run module. It's gonna save. We get name true is not defined. Why is that? This is your first lesson in syntax. That's why this lesson is called syntax. True is not understood by Python. That's because true needs to be capitalized. You notice it turned purple now. So now let's try running it. File, run module. So now we get true printed out. And so we can do a little bit more advanced stuff. We can go bool equals 1, and if we run it, we get 1. However, 1 is usually known as true. So just be aware that Python doesn't necessarily know that you mean true when you type 1. In most instances, you'll have to type true or false. Of course, spelling counts too. And when we run that, this time we get false. One more important variable type is what's called a float. Notice it turns purple. A float is a number that has, basically it's a decimal number. So 1.23456.7. Now it has a certain size. It can only have a certain number of trailing digits. So if I went 7, 8, 9, 10, 11, 12, 13, it's going to cut it off somewhere around 7. And if you had something like 1, 2, 3, 4, 5 decimal 6, 7, 8, 9, 10, whatever, it's going to cut it off somewhere around the same point. So they have a limit to how accurate they can be. So this brings in the rules of how big can our containers be. Let me finish describing floats though. So float, like I said, is a decimal number. So we can say a float is equal to 3.14, like pi. So if we say let's go float 01 equals 3.14, print float 01, run it, we get print 01 is not defined. That's because I don't know why I put print float 01, run it, we get 3.14. But let's look at something interesting. Let's use our first data type, just a basic number, which by the way is called an integer. So sometimes you'll see int 01 is equal to 3. So we have an integer, a basic number, 3, and we have a float, a more accurate decimal number equal to 3.14. What happens if we add them? So float 01 plus int 01. When we run that, we get 6.14. It adds the decimal onto the integer, onto the basic number. However, you can run into issues if I was to do something like var 03 equals int. So what I'm doing now is I'm turning an integer into something else. So int float 01 plus int 01. So what I'm doing is I'm taking float 01 and I'm adding integer 01. So 3.14 plus 3. So we would get 6.14 just like we printed here. But we're going to get rid of that because that was what we did last time. This time we're going to print var 03. So var 03, and var is short for variable, is going to be float 01 plus int 01. But notice that I've surrounded it with brackets and I've typed int, which is again short for integer, before it. So what that means is whatever number this adds up to, we're converting to an integer, which remember is just a basic number. So you would expect 6.14, but when we run it, we get 6. It cuts off the difference. So you have to be careful sometimes. You can lose accuracy if you're not careful. So generally, if you're working with decimals, it's best to always use a float. So you'll notice when I type in the basic data types, they turn in purple. So let's just look at them in detail again and review. So we have our basic numbers called integers. So an int, aka an integer, is a whole number. And this is what I said I was going to go over. And it's basically between about 2 billion and plus 2 billion. So There's a little bit more and less on those numbers, but that's roughly the limit. So you can have any number in there. Then we have float, or sorry, then we talked about Booleans. So bool is the shorthand form for it. Boolean is true or false. And so it can only be true or false, sometimes shortened to T or F, sometimes shortened to 1 or 0. And so that's used as a way to go one way or the other. You could call it a fork in the road. Then we had a float, which is exactly as it is named, which is like a decimal number. So it's something like 3.14 for pi. However, it has the limit that it will cut you off at about 15 to 16 significant digits. So a significant digit is all leading zeros, trailing zeros, and any digits in between. So if I went 0, 0, 0, 0, 0, let's go 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. Actually, I'm going to stop at 11, 3.14, 1, 2, 3, 4, 5. So we'd have 15 zeros plus 3.14 in the middle. If my float equals that, and then print my float in brackets, and then run it, F5, a spelling mistake. And also that I didn't capitalize the F. Run module. We get 3.14. So it cut off all those extra numbers that we could have used. So we could have 3.14, 1 whatever. So let's go up. So our last digits were 1865. It cuts it off at 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11 significant digits. So you can lose accuracy. However, this is about the most accurate you will get in coding, is using a float in Python. In other languages, there's other ones that bring in more precision, but that's about as precise as you can get. So we now know how to store numbers in a container. So my int equals 1, and we've learned how to print them. But what about changing them? Remember I said that when we did int02 equals 2, if we did my int plus int02, that it wouldn't change these numbers at all, even though we're adding them in the print statement? What if we wanted to change them? Well, to do that, it's as simple as saying, let's go int02 equals 5. And then let's do the same. Let's see what the results are. So as you can see, we get 3, which is 1 plus 2, and then we change the 2 into a 5, so that's 1 plus 5, and we get 6. So you can change what's contained in your variable containers just by typing in an equal again, an equal sign, that is. Now remember I talked about white space, things like spaces and tabs, which are 4 spaces into 1. That's another very important thing when it comes to syntax. So if we use, now this is a bit more advanced that we'll talk about later, but the def statement to create a function, we'll call it my function, or let's just call it example. You don't have to worry about any of this. When we hit enter, it automatically gives us an indentation of 4 spaces or 1 tab. And so we could say something like int1 equals 5, and then return int1. Oops, I'm thinking about other languages here. And then we could go, if I hit enter again, now it knows that we're done with that, so there's no more white space. And then I go print example. So what is going to happen? So we hit F5 to run it, we get 5. So that's because the white space is here. What happens if we get rid of it? I'm going to delete the white space at the first line and try to run it. We get an error and it tells us it expected an indented block. So we give it an indent by pressing tab or giving it 4 spaces. What if we get rid of it at the end? That doesn't run either. It says that the return is outside of the function, so it's smart enough to know that this return statement should be up here, but it knows that something's not quite right. It knows it needs to be a part of it, so we do that by indenting it. So this is all considered a block now. It's all in one. It's all part of each other. We can put stuff above it, and we can put stuff below it, and it won't change what happens. No matter what, we still get 5. Now let's talk about comments. So you saw at the beginning how I used the pound symbol and typed in something that the compiler would give us errors about. If I run this, I still get 5, but if I get rid of that single pound sign, now it's going to give me an error that it doesn't know what any of this means. So what this pound sign does is it's a comment. It's a note. It allows us to leave notes to ourselves and to people that may be reading our code in the future. So we can say, and we can put these anywhere. So I'm going to say this integer is set to 5 because we have 5 of something. I don't know. Then we say, and again this is more advanced, but example function returns 5. 5 is this number is important to us. This is the return line, which tells us what example equals. This is a print statement we learned very early. Another integer that does nothing. So if we run this, even though we've added all that junk, it still gives us 5. So it allows us to be able to tell people what our program is doing and leave notes for ourselves when things get very, very advanced and complicated. We have thousands of lines to work with. So that's just simply called a comment. Lastly, if you want to create multiple lines of comments, you could just put pound, 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 but that looks a little bit ugly. So what they thought of is that you can use 3 quotation marks. So that's 1, 2, 3. So notice how it turned everything green? Now there's no program at all here. When I run it, it's just going to be blank. Well, it knows that we have an error. We triple quoted. So if we hit enter a few times and then do 3 more, it goes back. And now in between here, we can write anything, anywhere, and it doesn't get in the way of the program. So when we run that, we still get 5. So that is the basic syntax of Python. It's pretty easy. You just have to remember basically that when you have a block of something, it might require indentation of 1 tab or 4 spaces. So when something gives you an indent error, just add 4 spaces or hit the tab key and try it again. And remember that spelling counts, obviously, but so does something called case sensitivity. So F is not the same as F. So if we had my variable, that is not the same as my variable. Those can be 2 completely separate variables. My variable equals 1, my variable equals 2, print my variable, print my variable. You'll see that we should get 1 and 2, not 1 1 or 2 2. We get 2 1. So that's pretty much the basics of the syntax of Python. So in the next lesson, we will go into math, because most programming, when you think about it, you're working with numbers, you're solving problems, you're basically doing math. When you get down to the core of it, everything is pretty much just math when you really dig down to how things are working. When I say my bool variable called cool var is equal to true, that really means that I'm saying some part of memory in my computer is a little container and it's storing the number 1 for use later. And then later in the program, when I say if something is equal to cool var, that means I'm saying is something true. If something is true, then we do this, and so on. And so you'll see that we have another block here, and that's where the indentation comes in. But we'll get more into that. So we're going to talk about mathematics in the next lesson. So hopefully you guys learned some stuff. And again, let me know what you thought about my lessons, if they're too long, too short, too detailed, not detailed enough, and if you enjoyed them, so that I can continually improve my videos based on your community input. So we will talk to you guys next time about math, and remember, create your way.